Hello everyone. So today we are going to discuss about some functions of the Rigid-Flex design. That is about your exploring the Rigid-Flex design in Altium Designer. I am Rajeshwari, application engineer from PCB GraphTech Singapore. So let us go to the agenda. So today we are going to discuss what are the reasons we go for Rigid-Flex design and some of the flex materials we can use for the Rigid-Flex design and some of the tips how to do the routing in the Rigid-Flex. Then what type of polygon pour can we pour in the flex design. Okay, so we are going to see them, and along with that we are going to see the demo. So now we'll go for the first topic, why Rigid-Flex. Okay, so we need to use Rigid-Flex in our next design means there are several reasons behind it. Okay, so we have to consider the reasons like your form factor, space saver, and reduce the weight, money saver. All these factors you need to consider. First, if you go for form factor. So for example, if you have a flex circuit and which is placed on any of the odd shape of your board, and that is a very good option we have to consider, because when you have the flex circuit which is placed on odd shape, for example, you can see in the right side, the top picture, there is a camera, and top of the camera there is a flex circuit. Okay, so this is one of the good feature for considering the form factor. So whereas when you take the rigid board, it is not possible. Okay, so this flex circuit which is wrapped around that odd shaped object. Okay, so we need to consider this. Second factor, you have to go for space saver. So normally when you design any board, we will consider along your X and Y axis. Okay, XY direction. So it will be a rectangular board or some shape. Okay, but normally if you want to reduce the size of the board, okay, you can increase the height. Instead of going towards your X and Y, you can increase in the Z direction, that is along your upwards, by placing your components in the stack up. Increasing the components in the stack up, you can see the second picture here. That is, you're reducing the size along your XY direction and increasing the size along the upward direction. Okay, so this will minimize the space and size of your board. Okay, this is the second reason we go for the Rigid-Flex design. Then third one is we can go for the reduced weight. Okay, normally if you consider the rigid boards, so rigid boards, when you're connecting the rigid board to any of your connectors or cables, so two or more rigid boards, when you're connecting, the weight will be more. Okay, so the weight is more, automatically if you're the space occupied is also more. So to reduce that, we can use a flexible board. Okay, so rigid flex, you can combine it, and so that it will reduce the weight. Okay, so this is the third one reason. The last one is money saver. So when you go for money saver, again based on the reducing the material. So first option is, as I told you before, you can go for taking the multiple rigid board. What happened when you're connecting to the connectors, cables? So you need to buy separate connectors, separate cables, so the cost increases. Okay, so to reduce, you can just use the Rigid-Flex design, and then when you can also reduce the size. When you go for Rigid-Flex, the size can be reduced, and then the weight also can be reduced. Okay, which can be packed in a small box, and the shipping cost you can reduce. So these are all the things you can consider when you go for your design. But when you go for the manufacturer, that is your fabricator, that time, if you consider your Rigid-Flex design, the cost is expensive. So you need to take care of it also, because you need to consult with your manufacturer when you go for Rigid-Flex design, what type of material you use and how about the cost. So it is not related to the manufacturer. Based on the money saver, it is related to the size and related to the space you occupy for your design. Okay. So next we are going to see what are the types of materials are available and what should we have to pick for this Rigid-Flex design. So here we have the first one is we consider the cover lay. Okay, so cover lay is a layer which is used on the rigid flex design. Normally, this is the outer layer. In a rigid flex design, we use this cover lay as an outer layer. In the picture, you can see in the right-hand side top picture, this cover lay is used at the outer layer. And the main purpose of this cover lay is to protect your inner circuit. Okay, you can see the inner circuit here. This inner circuit will be protected by this cover lay from the damage and the corrosion. Okay, that is the main purpose of this cover lay here. As well as it acts as an isolator to the adhesive. There is an adhesive here, okay, between the cover lay and the copper. So this adhesive is used to protect your copper and it acts as a bonding agent to the cover lay. Okay, so the adhesive is placed between the cover lay and the copper. Okay, so then the main important thing is the cover lay will act like a sandwich. Okay, it's like a sandwich covering your copper adhesive, and on the top we place this cover lay. So next we have to consider very important thing is, because we are going for rigid flex design. So in the rigid flex design, the thickness is very important. Okay, as the thickness of the board increases, okay, automatically, so the thickness increases means the flexibility will start reduces. Okay, so what you have to do in your rigid flex design, if you have a sharp bend for your flex design, there is a sharp bend radius. So at that case, your cover lay on the top layer should have a very thin cover lay. That is very important. So the considering a sharp bend of radius, the cover lay should be very thin. Okay, so this is the consideration you need to do. Then coming to the signal layer. Okay, so signal layer is nothing but the copper layer. So copper layer, there are two types of copper you can use. One is electro-deposited copper, then the rolled anneal copper. So you can use these two copper in your flex design. So normally if you use a standard copper, instead of these two, if you use a standard copper in your flex design, what will happen? It will try, when you try to bend, it will break. Okay, so we don't use the normal copper. Instead, we can go for roll anneal copper. So what happens when you use the roll anneal copper, you can see the picture, the third picture here. In the roll anneal copper, you use reducing rollers, okay, to make it very uniform texture. You just press the reducing rollers to make a uniform structure and more springy. Okay, we make it more springy and then we use it. So it becomes very smooth and very nice to use for any dynamic flex design. Okay, so it is very good to use in flex design, but it is a little bit expensive when you go for rolled anneal copper. Okay, so when you go for this electro-deposited copper, this is can use for static flex design, meaning if you don't want to open and close regular, once a while, okay, you want to close and open like 2 month once or 3 month once, you want to just close and open your flex design, you can go for electro deposited, which is a little bit cheaper as well, okay, compared to the rolled anneal copper. Okay, you can use that. Then going to the dielectric. So when you go for dielectric material, what type of material you can use? Like polyimide, polyester you can use. So when you go for polyimide material, okay, we have to consider it is very flexible. Okay, that it's flexible and it is very tough as well. So tough means you cannot stretch it easily by hand. Okay, you cannot stretch easily by hand. Also, it cannot be tear. Okay, it is heat resistant. So then it can also used under any hot temperatures. So we have so many advantages for polyimide material, but we need to consider it is a little bit expensive compared to the polyester. So polyester is very cheap, but it is not heat resistant. Okay, it is not heat resistant, and then it is less in weight as well. The polyester is less in weight, so it cannot be handled under high temperature. Okay, so when it is based on your design, you need to consider the material. It doesn't mean when I say the polyimide is very hot, tough, and it is very good, and but it is expensive, you can use it. Doesn't mean that based on your design, you can choose your materials. Okay, so here, let me show you in the software how to see your materials in your layer stack manager. So let me go for the software here, and then I have a board. Let me open the layer stack manager. So you can see the layer stack manager here. I have the rigid stack, flex stack. So I want to see only the flex stack. Let me go to the flex stack here. So you can see the flex stack usually has the cover layer here. Okay, so cover layer, then signal layer, then dielectric. Okay, so these three only we were discussing now. So the cover layer we can use as a top layer, which protects your inner circuit of your flex design. Signal layer is made of copper, that is can be rolled annealed copper, or it can be your electro deposited copper. Then the dielectric can be polyimide or polyester, you can choose. Okay, so this is about your layer stack material, which you can use it in for your flex stack region. Okay, so now let me go to the slide. So here next we go for routing tips. Okay, when you go for the routing tips, so what are the things you need to consider in your flex? Okay, so when you have a flex design, very important thing is in your board planning mode, we will be placing the bending line. That is very important. So when you have the bending line, you need to consider the bending radius, and based on the bending radius, we need to check where to put your bending line. That is very, very important. Okay, so if you have a sharp bending angle, then you will not have the routing will be very sharp, and it will give a lot of reflections, all these problem. So always you have to have a contour angle. That is, it will be, your angle should be a very smooth, and it should be as a curved angle of routing should be followed in your flex area, because in the flex area you will be having you will be moving, bending, all this you will be doing there. So your angle of routing should be very smoother here. Okay, so the bending line is preferred place. You can see in the first picture curve, there is a red color preferred. This is the preferred area to place your bending line. Okay, and you cannot place your bending line at this place which is not perpendicular to your routing. Usually a bending line should be perpendicular to your routing. Okay, so you can have the smooth and curved routing lines here. Okay, so next, when you consider perpendicular to the bending lines, and then we have to go for seeing your IPC standard also. So there is some IPC standard version here. You can see there is a dynamic preferred flex to install. You can see this is the bending area you need to consider. This is preferred. Okay, you shouldn't place your bending area somewhere where the routing is bending all this. Okay, so you should select, that is very important to select the bending line and then the bend angle radius of your routing. Okay, so these are all the preferred settings which is taken from the IPC standard we can consider. And then next, if you go on the top second picture, you can see about the avoid abrupt width changes. So what is this avoid abrupt width changes means? You will have, sometimes you will have your pad in the flex area. So when you have the flex here, when you have the pads in the flex area, and if you start routing, you can see the width of the trace. The width of the trace touching to the pad. Okay, so this is called the weak spot. So the pad width and the trace width are different. So this is called the weak spot, and it is not preferred in the flex area, which reduces the flexibility and reliability of the board. Okay, so what we need to do, we have to place the teardrop. Okay, if you place the teardrop, you can see there will not be abrupt change in the signal. Okay, so the width will be slowly, you can put a teardrop here so that the signal pass through the trace from pad to trace. Okay, you need to consider like this. Then when you go for the staggered traces, so staggered traces is nothing but, you can see the third picture here. Here on the, you have a 2-layer board. In the 2-layer board, we have on the top traces, and the below you have trace. So there is a gap between the one and the other trace. Okay, there should be a maximized spacing should be there. Okay, so this is correct preferred construction to place your staggered traces. But when you go for the below I-beam construction, in your flex design, if you go for I-beam construction, you see the staggered traces one below the other. So this is not preferred, and it will give you the return path, all the problems. Okay, so we don't recommend to use the staggered traces in this manner. Okay, you can use the staggered traces similar to this picture. Okay, so now let me show you how to do this routing inside the software. Okay, so let me open the software here. Okay, I'm going to show you. Here we have this board. So if you want to flip the board, you can press Control F to flip the board and see here. And I want to see my board in the board planning mode. You can see. So the board planning mode, I have my bending lines here. Okay, the bending lines are here. So now I'm going to show how to do the routing, which is perpendicular to this bending lines. Okay, let me go here. So I start routing here. Go to route, interactive routing. Okay, let me start routing from here. And then you can see the routing comes here. So here, when I go for routing, you can just see I can follow here. Okay, so it is, I'm using 90 by 90 vertical start with arc. So with arc, so it can be going with the arc. Then I can see I can just do this. Okay, so now I can do the smooth routing here. So once I finish the routing, if I want to adjust my arc, I can adjust it like just dragging the arc here. So it will be very smooth to adjust it here. Now I want to follow the contour routing. Okay, the other routings I need to draw. So I just go for again routing and then start for the second contour here. When I start here, I want to follow the routing based on my first line. Okay, first line I want to follow. So I want to follow the same shape, all this. There is a shortcut called Shift F. When I press Shift F, it will default follow with the previous routing arc. You see, it follows with the default previous routing angle shape. So it is easy for me to easily draw the next routings. I no need to struggle that I how to follow the same path or all this. Okay, you can do this routing. Then if I want to do the same thing for the last line, okay, so if instead of following the first routing, you can also follow this the board outline. I want to follow the board outline routing. Okay, so you can also do that. Okay, you can press Shift F and then you can follow. Okay, you see it is following, but when it is following, it will follow with respect to the design rules. Based on the design rules clearance, it will follow for me to do the routing here. Okay, so now what I'm going to do is, I'm not going to do in the single individual routing. Instead, I'm going to do the multi-routing. Okay, multi-routing means that is very important in a flex circuit, how to do the multiple routing. So let me select all the points here. So once I selected all the net, I'm going to do the multiple routing here. So to do the multiple routing, go to route, interactive multiple routing. So let me do the start multiple routing here. So when I do here, you can see, so I have the multiple routing. So let me click and then let me see, you can see here, it is very smooth and very nice. You are getting the multiple routing here. Okay, so just click, then you can, let me show you here. Yeah, you can see here. So the multiple routing, you can place it here, click. Okay, so once you're done, come out of it. Now, if you want to adjust it, okay, so I want to, for example, I want to adjust this area. So I want to make it very glossy. Okay, glossy and neat. You can just select it and little bit drag. At what size you want, you can little bit drag and then just leave it off. Okay, so now why I did this actually is, in the flex area, you have the routing and there is a gap. Okay, between your routing nets and the border line, you have some gap. This is very important to have. Okay, why we need to have is, we are going to place the adhesive layer as well as the cover layer. Okay, so since we are placing these two, there should be a gap. Okay, so that's why we are giving some gap on the between the board outline and the starting of your trace. Okay, so both the side you can see, as well as you can see in all the sides here, we are giving the spacing when you are drawing from the two. Okay, now let me show you in the board planning mode. You can see this is what I was explaining in the slide. Your bending line should be perpendicular to your routing trace. Okay, so all my bending lines are perpendicular, which is preferred, and you can see the bending lines are not at the edges, or it is at the center, it is not at the curved point. Okay, so this is very important to consider. Okay, so now we have drawn this routing. The next step is I'm going to connect it. As I told you, if you have your, for example, if you are having your pad in your flex area, the pad width should be connected to the trace width, should not be abrupt change. That is, the width shouldn't be same. Okay, connecting of your pad and the trace. So to avoid that abrupt with the change, I'm going to show you with an example. So let me go for the routing and let me go for the routing. Okay, let me click here and then you can see, let me change shift space bar. Okay, so I change here and then let me connect it here. Okay, then this is for example, I want to show you how to add the teardrop when you're using in the flex area, but I'm not using in the only flex area. I'm connecting between flex and this is my rigid area. Okay, so but I'm going to show you how the pad should be connected to the trace. Okay, if you have the pad in the flex area, you can also do the same thing. Okay, so I'm just showing you the example. Okay, for example, let me select the 4 traces, not all the traces, just the 4 traces for the. Okay, so I have taken this, drawn this trace to the pad here. So now you can see how the pad connected to the traces, right? So I don't want to give the abrupt with the changes. So to avoid it, we can add the teardrops. Okay, so to add the teardrops, we can go to tools, we can go to teardrops. So now you can see under the teardrops, we can add your via or through hole pad, then SMD pad, tracks, T-junction. So it makes me smoother here. I change the percentage, for example, to 50%. Okay, so the teardrops should be very smooth here. And considering I also allow the forced teardrops here. So giving some of the options. So here the T-junction, it following 100%, the 300%. This is your own settings. For your own teardrops, you can set it off. So just click OK. You will be able to see the teardrops here. Okay, so this is why we give this teardrop. The very important thing is to have more flexibility and reliability of the board, because we are connecting between rigid and flex design. So in the rigid area, if the pad is there and the trace is there, both the width are entirely different. You use a different width of the trace, then the pad width is different. So to avoid the problems like your reliability, so we just add a teardrops, so which increases your flexibility and the reliability of your board. Okay, you can do this. So now next what I'm going to do is we are going to add the staggered trace. Okay, so to add the staggered trace, let me show you how to add the staggered trace. So this is what we are seeing in the slide, how to add the staggered trace. So let me change the layer. Okay, I choose the signal layer 2, which is a ground layer here. I'm going to add the staggered trace. So staggered trace, I'm adding in this signal layer 2. Okay, so I just go for route. Okay, let me go here, select one of the trace. You can see the staggered trace I'm using in the signal layer 2. If I want to change the width of the trace, okay, just press the tab key. Let me change the width here to be 0.1. Okay, 0.1. Okay, you can see the staggered trace here. Okay, you can add your staggered trace, so which is in the signal layer 2. Okay, similar way you can draw for the other layers. Instead of drawing one by one, you can also select the traces and then create the staggered trace. For example, if you see, let me select some of the trace. You can see here, I will select some trace and then create the staggered trace. Okay, so select it, press the tab key. Then in the properties panel, I just change to signal layer. Okay, you can see the staggered traces. Okay, so you have added the stagger traces with the signal layer 2. So this is how you can add the staggered traces by just selecting the nets. Okay, so next step is we are going to see how to, this also will be maximize the spacing. Okay, here as I add the staggered trace, I done in the another layer, and this staggered trace will also help to maximize the spacing between the layers. Okay, so now let me go to the slides again, and then we will go for the next one is about your polygon placement. Okay, so this polygon placement is usually if you take a copper, we pour copper, usually we go for solid copper. So when you pour the solid copper for the flex board, it is very hard. Solid copper will be hard. So what happens, your flex region, when it is bent, it will break. Okay, so the solid copper is not comfortable, convenient for the flex. It is not reliable for your board as well. So we have to go for hatched copper. So when you go for hatched copper, there are different types are there. Based on the 45 degree, we can go for the copper here. You can see hatched pattern, 45 degree hatched pattern. Then the second one is honeycomb hatched pattern copper. Then the last one is 90 degree. Okay, so there are different hatch patterns are there. You can use which one you want for your design. So normally, as I told you, when you use solid copper, it will break. So here, when you're using this hatched copper, what is the advantage is they are only at the certain lines. So the remaining areas, it will remove the copper. Okay, it will remove the copper and it will flow only at that particular 45 degree of the lines. Okay, so it will reduce the copper amount inside the design. Okay, we will see inside the software. I will show you how it works. So we go to this design. Now I'm going to show you how to pour the copper here. For example, I'm again in the signal layer 2. Let me click on this. You see there is a copper already. If I try to extend this copper, okay, you can see when I try to extend this copper for a certain area. Okay, let me do this. You can see automatically it is creating the copper and it is a solid copper. Okay, so there is, because this area is a rigid area and this right side is a rigid, but in between is the flex. So I cannot use this copper to be used in the rigid area as well as the flex area. Okay, so I cannot use this. Let me go for, I just go for remove this. I want to create a new copper because I'm going to create only for the flex area instead of the rigid. Okay, so to do that, let me go for copper pour and I'm going to try to create it. So here you can see, let me do here from the top. Okay, okay, let me do here. Okay, so now when I draw this area for copper, you can see in the properties panel, here you have the solid copper and hatched copper. So now I need to connect it to the net. So let me click on the edit net and I use the ground net. Okay, so I'm using ground net and the signal layer 2, it is a hatched copper, but you can see the copper poured is in the horizontal lines. So you can use the horizontal copper, but you can see there is a trace on the copper. Some traces are below the copper and some traces are away from the copper. So this horizontal hatching is not preferred. Okay, because some are not inside some traces are not inside this copper. So if you go for the vertical, the same condition. Some will be in the trace and some of the traces are not inside the copper. So this is also not suitable method of using the copper. So let us go for 90 degree. So 90 degree is better. You can see in the 90 degree, you have the copper, hatched copper here, but you can see some traces are within and some traces are not within the 90 degree as well. So for this condition, we can go, next one is 45 degree. Okay, so the best method to use is 45 degree at 45 angle. So it can touch all the traces in below the copper. Also, you will need to use pour over all same net objects. Okay, so we use the option and then we pour the copper. You can see it is more better. Okay, compared to the other options, it is better. Then coming to the right hand side, here you can see there is a rigid area. Okay, so we pour the copper here and it is a hashed pattern and it is more comfortable for flexing all these things and it is more reliable to my board. Okay, so now I'm going to draw the copper here in this area, which is a rigid area. Okay, so again, I'm going to do the copper pour here. So let me do it. Okay, I draw the copper pour. Okay, so I just go to the properties, then edit so I just edited. Then we have the copper, hatched copper here. then we can I go for solid because it is a rigid area. So I don't want the hatched pattern. I go for solid copper, pour over same net objects. Now you can see this is a rigid copper and then hatched copper. You can see here the difference. So the rigid area has the rigid copper, that is a solid copper, and the flex area has the hatched pattern. Next, very important thing is, even though I use the 45-degree, I need to consider one more very important thing. For high-speed design, high-frequency circuits, there is a possibility for the high-speed trace. Okay, you have a high-speed trace means there will be a signal integrity issue. Okay, so because we have hatched pattern here with the angle of 45-degree, so in the written part, the signal integrity will be degraded. Okay, so how to avoid that problem? Okay, for example, I have a net, high-speed net, and it is having the signal integrity is degrading. So to overcome the problem, let me show you. I will just shelve this polygon for a while and then do something. Okay, let me shelve it first. So what I'm going to do, I'm going to place the trace in this layer, high-speed trace. I'm going to place a trace here. So let me go to the tools, routing, and then let me consider the third trace here. Okay, when I consider, please remember your trace, what you are drawing should be bigger than the trace available. So let me press the tab key. I change the size of this trace to be 0.13. Why I draw this trace is mainly to avoid the return path. Okay, to avoid the return path for the high-speed net, meaning I'm considering the third trace as a high-speed net. So to avoid the return path problem, I'm placing the solid copper as a trace net inside this ground layer. Okay, to avoid that problem. So let me, okay, change the angle of routing. Okay, so ignore obstacle. Okay, let me do here. Shift space bar. Okay, let me do this. You can see here, I'm just drawing. So I'm using the third net. Let me draw first, then adjust the size. Okay. So now I have drawn this. Let me adjust this to the third trace. You can see I'm just exactly placing on the third trace to avoid the return path loss, all these for that particular high-speed net. Okay. So I just adjust the trace here. Okay, now I have properly placed on the particular high-speed net. Okay, so now let me bring in the copper pour. So I just, to bring in the copper pour, right click, polygon action, go to the polygon manager. So here I have shelved this, so I bring it back. So, okay. So now you can see, I brought in my hatched copper, and then you can see this below, there is the trace. Okay, this is the trace I placed in this layer to avoid the high speed net problem, that is signal integrity problem, because it's a high speed net. Sure, it will have the return path problem. So to avoid it, I place a solid copper in this layer behind that particular net. Okay, you can do this here. Okay, so this is how you can place your copper. And then next, one more important feature we are going to see. The last one is about your new enhancements in your Rigid-Flex. Okay, the new enhancements is like your individual substack regions, which was introduced in the latest version of the Altium Designer. Is like you can see here, you have the individual substack regions. So previously, you will not have the bending lines at the edges of the board. Now you can have the bending lines at the edges of the board. You can have the bending lines at the cutouts. All this you can have. Also, we have now selective bonding, book binding in the layer stack manager. Then we have the folding inside the cutout. Okay, so all these features are introduced in the latest version of the Altium Designer, which increases the complex geometry and made it to be so easy now in Altium Designer. These features are implemented, can be done in the board planning mode itself. Okay, so normally if you open your Altium Designer, you can see only the legacy version of your Rigid-Flex. If you want to change it, you have to remove the legacy from the preference. Okay, then you will be able to see the new features in the Altium Designer. Okay, so let me show you the demo of this topic. I will open the, let me open the stiffener example. Okay, so here I have the stiffener example. So actually it's in the 2D mode. So when I go to the board planning mode, I just open here. So here you will see individual region. Okay, individual stack region, you can click to see it. But usually in your version up to earlier versions, you cannot able to edit the board regions. You cannot adjust, or you cannot move, or you cannot do any changes. But now you can select and you can see the properties of that each board regions now. Okay, for example, I select this region, you will see the board region properties. Okay, and if you want to change the color of the particular region, you can select it and change the color. So the color change, you can see it here, and what layer stack is used, all the information you can see, whether it is the priority level and whether it's 3D locked or not. Okay, then if you want to adjust select the second area, for example, let me select this, and then you see I want to adjust the size of this stack region. You can adjust the stack. Okay, you can see here when you're adjusting. Okay, let me see the properties panel. I think in the properties is all layers selected. Now let me select this, and then let me here move it. Okay, you can see there is a dot here. Just click to place it at the end of this. Okay, so you can adjust the size of the board region. This feature was not available in the earlier versions. So now you can adjust your board regions. All these can be done in the board planning mode itself. Okay, next thing is if you want to add the stiffener, now you can add the stiffener for your Rigid-Flex design inside your layer stack manager. So you can go for design, layer stack manager. Okay, so now let me see the flex area. So R2 plus stiffener. If you want to add your stiffener, you can go for add, and then you can add your stiffener here or adhesive here. Okay, so stiffener is normally will be like giving some rigidity of your flex area. Okay, just you want to increase the rigidness in the flex area, you can add the stiffener. Okay, that is the main purpose of it. You can use it there. Okay, that is the rigid stiffener example. Next one is about your cutout area. Okay, this example I'm going to show you is, let me go to the board planning mode. You see there is a rigid area. Inside the rigid area, you have the flex as well as the board cutout. Okay, you can click here to see the regions. You can see the region, the properties of each area of the board. So if you click, you can see the properties of this rigid board. Then if you want to see the properties of this rigid or flex area, you can click, you can see F3 R1. So if I click F3, you see the properties. This is flex 2. Okay, the flex 2 area, and then what is the priority level, and what is the flex used for this layer stack, all this information. Okay, you can see it here. And then the main advantage is now you can see the bending line here. So the bending line can be placed in the cutout, and the bending line placed at the end of the board as well. Edges of the board, you can place the bending line. These are the new enhancement features introduced in the latest version of Altium Designer. Okay, so you can see the priority level. When the high priority level is given, so they will follow based on the bending in 3D view, they will follow this priority level. Okay, suppose if you want to adjust, you see here, I have the flex area, and then let me choose this area. And if I want to adjust this flex area, the size, you can increase or decrease. Okay, when you increase or decrease, now I want to see this in the 3D view. You can press 3, and then you can see here. So I have increased the length of the flex area. So you can see this. When I press 5, you can see how nicely it is bent. Okay, so you can see the flex area and the rigid, how nicely it is bent in all the. Okay, not only in the center, you can see at the edges also, based on the cutout, the bending line is there and they are smooth. Due to the stiffener, there's the bending adjustments are done. Okay. So this is how you can do these are the improvements have been implemented in the latest version of the Altium Designer. All you can you can do it in the board planning mode itself. Then you can see the results in the 3D view. Okay, thank you for attending the webinar. If you have any questions, you can write your email to sales@pcbgt.com.sg. Okay, thank you for attending the webinar. See you all in the next webinar. Okay, thank you.